DevStream. DevStream is now. I think I'll speak in this evil voice today, just because I can. Today, we're doing something very strange. One of the slowest parts of Ennuicastr is the stupid task of measuring the duration of the recording. It shouldn't be that slow. But I have a solution in order to measure a recording. Okay, so the problem is that the duration... So I need the duration of each track, but they're all in a single file, because it's just everything in the order that it was received. So the way that you get the duration in the current implementation, let me show you aug duration, which is all I'm using to get the duration of the current implementation, written so recently. It literally just goes through every single aug packet in the aug file, checks its location, and then if you're asking for a particular track, it checks whether that's the stream number, and there it is. So it literally goes one by one through every single packet in the entire file. Now, there are certain aspects of this that are unavoidable. There are certain aspects that are that are just plain stupid. The biggest problem is on a very large file, this is horrendously slow. And that's particularly a problem because, like, if I have multiple tracks in a file, then I'm actually getting the duration of all of the tracks. So, what do we do about that? Well, I don't know. So, what do we do about that? First of all, I can start from the end, and that's all that I have started on so far. And I thought this was going to be a really quick thing, so I wasn't going to do it on stream. But there are various problems with it. So first of all, since I'm getting the duration, I need the offset of the first. So they're called granule positions. It's just an aug thing. I need the offset of the first packet, but I don't have that if I'm starting from the end. And second, although you would generally expect to find things at the end, a track can end at any point. It's just as long as whoever was speaking. And so you actually need to sort of go backwards. So I have this search where I am just going, in powers of 2, starting at 1024, but I'm going to change that to 4096. But the way this is currently implemented, I'm then reading to the end, so I've made an O of n problem, O of n log n, albeit expected lower total time. So I need to fix this to be O of n again, instead of O of n log n. The other problem is this has to happen for every track, and if there are a lot of tracks, then now I've made it, what? N squared log squared n, or, n log n squared, which is quite bad, but it's even n, well, no, it's not n squared, it's nm, actually. It's, nm log n. Yes, where n is the length of the file and m is the number of tracks. But that's still quite bad. So I want to be able to search all at once, and I want to be able to search from the end. Those are my goals. Oh, and I want to fix this first granule position problem. So many problems to fix, actually. This is almost like a start from scratch thing, so I'm gonna restart main and sort of take it one step at a time here. So if I want to do every track, so the way this works is that there are 2 header files and a data file. The 2 header files are for they tell you how many tracks there are and such, and the data file contains all of the actual track data. So I need to open all of them, read the headers to know how many tracks there are, Thinking. I want this to be C++. Normally, I'm quite happy to do something with C if C will do, but I'm going to want an unordered map here, so I want this to be C++. So I certainly want fcntl. I'm going to need sysstat, systypes, unisted. Going to remove other things to encourage myself to actually use C++. Read, I think, is unisted, right? Yes, so that's fine. Main is going to be very different. I want unordered map. Going to bring standard in, since this is just a C++ file, not a header. One step at a time. One step at a time. One step at a time. So the way I'm going to do this is I'm going to have the output be the duration of the entire file and then the duration of every track, one by one. So first, I need to figure out what tracks exist and get all of their duration. First, I need to figure out what tracks exist so that I can get all of their durations. This is actually going to be one file descriptor at a time, so I'm just going to call it FD. In spite of the fact that I'm doing this in C++, I am still a Unix guy, so I am just going to do raw file I/O. So argv1 will be the header 1. I'll have header 1, header 2, and data be the actual command line arguments. Read only. Okay, so I will obviously need to know how much I've read. Let's go ahead and get that. Yeah, fine, I'll need a buffer. In C, this was technically not allowed, although it's definitely allowed by C11. But in C++, that is definitely allowed. Okay, so reading a bit at a time. Of course, I'm just going to cannibalize this for most of what I'm doing. Oh, I see. Okay. Wait. I see. So I've got a pre-header and a header, right? Yeah. But the header is in there. So let's go ahead and get my pre-header structure back. For the time being, I don't know that I need buff because I'm going to be using pre-header here. So while read all fd pre-header size of pre-header equals size of pre-header. This is slightly annoying because I'm going to have to do some duplication here, and I'm trying to think of a better way to do it. I mean, I could do it with, like, lambdas or something, but then it would be very, very difficult to change it when I'm trying to go from the end to the beginning. So for the time being, I can't really think of a better way to do this. The thing is, just this, like, I mean, I could at least do the skipping in a less stupid way, I suppose. Okay, so we get the actual header data. packet size. So you went 32, fine. You know what? I'm just going to unify that into a function. I am so C. I just live in C. Look at this. Even that is C of me. Oh, look at that. I did it there too. I am a C boy. Weird to have the it's Pascal to have the return have the same name as the function. That's a Pascal joke for anybody who knows Pascal. Am I even remembering the right programming language? I think it is Pascal. Or to return, you just set the set a sort of phantom variable named for the function. How did I even manage to screw that up? I don't know. You know what? Since I literally never want the data, I'm just going to have a skip data function, and it'll handle both of these. Oh, this doesn't need the OG header. Why was I so confident that this needed the OG header? The segment count is just past the OG header. So all I need is the file descriptor. And then I will just use lseek to skip it. But I am not going to check the return to lseek, because if it fails, then I will just get back around to the header and fail there. So offset seek cur. I'm just going to skip past the packet size. Even that, I mean, that won't actually make it faster because most packets are quite small. But even that, just not having to read into a buffer, certainly not a bad change. So zero size things are just a reference, as I said there. There's a timestamp reference, but for what I'm doing, it's actually harmless. It's just, you know. Oh wait, is it harmless? You know what? I am going to return the size. And then I will still skip if it's zero length. Okay, so we read the header, we read the pre-header, we check whether it has the right capture pattern. We read the header, we skip the data, and also check whether there is any data. Now, what I'm actually trying to do, I went for unordered map instantly, but I actually want a set. But I want an ordered set. Is there an ordered set? How does this work? Like if I make a set, can I get everything in the set in order? Must be able to, because there is such a thing as an unordered set. Stream number. So you went 32T, fine. Set, you went 32T. Tracks dot. How do I just put something in this? Dot insert. That'll do. It's just a number, so I don't need to worry about the distinction between insert and in place. And I want og header dot stream now. I'm trying to think about how this should be done, because I want to search from the end, but I only want to search the tracks that I still need to resolve. So I need a set of unresolved tracks that starts as a copy, yes, copy of tracks. While it is not empty, I think there's a, what my immediate thought was like if begin is not equal to end, but yeah, there we go. There is in fact a way to check whether it's empty with just empty. So while we still have tracks to resolve, so I actually don't need header 2, but I feel like I will confuse myself if I just don't have it be an argument, so I'm just going to have it be an argument and ignore it. It's also future-proofing in case at some point I actually need that argument. So this is actually arg3, and I'm just not dealing with arg2. And I want the stats on the file. Not fstat, because fstat is for a file star, right? No, fstat is for an fd. What am I thinking of? fseek. Fseek is what I'm thinking of. Fseek is for a file star. Fd, stat buff. This always returns 0, right? Yeah. That's not 0. Okay, so now we have the size. Search from is sb sbuff.st size minus search length. Search 2. I guess technically these shouldn't be size t, they should be off t. Search2 equals sbuff.st_size. It's going to be difficult to resolve any track if I don't actually keep the set of resolved, what am I trying to say? Keep the set of durations. This is unordered map. So from a track number to, what is the granule position? You went 64T, makes sense. Yeah, I forgot. I'm going to need to get that starting time, the first granule position. Call this start time. This should just be... Right, there can be some metadata that has 0, so it's not necessarily the first. Basically, I need the same loop as this. This is some nasty duplication. I've made it better with this skip data function, but not a lot better. If well, let me make sure that I've got a default here. Dot granule posts, then start time equals that granule posts or position posts. And I just break out of this loop. Okay. And I've somehow managed to enter X mode. Cool, great. Thinking very carefully. So I set it to search from. Again, I don't actually want to check the results. Yes, I do. Yes, I do. Here's how I want to check it. Because I want to actually know my exact position. So in this case, I should always know where I am. So this is like an unrecoverable error if somehow I can't seek. Like I know the entire size, and I know, and I'm always seeking within that size. So. It's just occurred to me that I could actually just have this be 4096 and just always search 4K at a time. Just search from the end to the beginning. This whole, like, powers of 2, there's not really any point to it. In which case, I probably want this to be more than 4096. I'll have it be 65536. Okay, so we go to search from now. We want to find an OG header. Interesting. I just did that 1024 at a time. That's actually fairly unwise, because if I landed in the middle of one at a 1024 buffer, I would miss it. I don't really want to miss it. Is there a better way for me to be doing this? Surely I didn't use char. I would never use char. I would use unsigned char. Yes. Allowing my characters to be signed. Disgusting. So I'm going to read at a sort of different rate and get it. Well, you'll see the trick. You'll see the trick. It'll be brilliant. It'll be brilliant if I do it right. It's a little bit tricky to get right. I need to think about this very, very carefully. Is in fact in string.h. My brain is on fire! Into buff plus 4. That's my trick to make sure that I can actually read between, like, the edges of my search parameter here, so to speak. Read size rather than buff size. I guess I can start from 1. Well, that's just going to be too confusing. So in this case, I've found it, but I have not thought of how I'm going to indicate that I've found it. What's even more tricky is how am I going to indicate that I haven't found it? Header pass equals. So it is my current position at the beginning of this read plus I minus 4, because the first 4 are not actually part of it. Yes. This isn't like a perfectly efficient way to do this, but og headers actually aren't that rare to find, so it's not a huge concern. If we've found it, then we break out. Otherwise, we haven't found it. So post plus equals red and memset buff. No, not memset, mem copy buff from buff plus buff size minus 4. No, buff plus 4 plus red minus 4 plus red to buff. Wait, to buff from buff plus red 4. Yes, because I read into buff plus 4. Man, that is a cause of needless confusion. Wait, how does this work? It just returns a negative number if it's wrong, right? Oh, it returns off t minus 1, which means less than 0 is probably not actually a correct check. My previous style of this is actually the right way to do it. Wait, I just said if it's not an error, then complain. This is an eclectic mix of C and C++ I'm making here. Again, this is a perfectly generic error because it simply shouldn't ever happen. Okay, so we have now seeked, hopefully, to an og header. God, it's this loop again, but it's going to be a slightly different version of this loop this time. Because this time I need to be keeping track of my position. Size of pre-header, checks that. Post plus equals size of og header, data size equals the result of skip data, and now the post plus equals that. Now we have the header read. I'm so unaccustomed to C++. Dot contains. I'm happy to assume C++ 20. Am I happy to assume C++? Sure, I'm happy to assume C++ 20. Wait, but all you would ever check with a set is whether it contains something. Why is this C++ 20? How are you supposed to do it before? Were you sort of seriously supposed to do find is not equal to end? Like, that's how you did it before? I think the answer is yes. That's how you did it before. C++ is a stupid programming language. Okay, so if it doesn't contain the track in question, stream no. Then we don't care about this. Otherwise, we're going to resolve this rack. Track durations. Yes, track durations for ogheader.streamNo equals ogheader.granule_post and resolved tracks.insert ogheader.streamNo. And then if the position is greater than or equal to search2, then we break. Okay. Now anything that we marked as resolved dot remove, dot delete, dot extract, dot clear. No, clear is clear everything. Erase erases elements. Is it seriously erase? What a stupid name. Yeah, that's horrendous. Because this whole loop is, while unresolved tracks is not empty. Okay, so search2 is what used to be search from. Search from minus equals search len. Wait. If search2, no, if search from is 0, then that means we're now done. Okay. Oops. Double oops, triple oops. If search from is greater than search2, that means we just overflowed. I'm almost positive that oft is a unsigned type, so less than 0 can't be true. But just in case. So if we looped around, then I'm going to set it to 0. Which means that is our final search. From track durations. Oh, I have to. No, it's a uint64t. Last granule position. duration dot second, because it's a pair, is greater than the last granular position we're currently aware of, then the last granular position we are now aware of is that one. Then we report. Track, not just of resolved tracks. We want of every track. So that's tracks. Let me start with the overall. I am going to use C++ style standard output. May as well at least pretend like I'm actually writing C++ here. So, what I want is last granule position divided by, last granule position minus first granule position minus first granule position divided by 48,000.0. The problem is that if we didn't get any duration information, this will be 0, in which case this will be negative. Is it possible for, well, I was about to say, is it possible for us not to get any granule information? Of course it is. Here's what I'm going to do. I'm going to make a helper function. So if track durations dot has or something contains, you know what, this would be better done with an iterator. Find, no, track durations dot find track if duration equals track durations dot end. I'm going to call this duration iterator. So default duration is 0. If it's not equal to end, that means that this is not 0, so the duration equals the duration iterator second, because it's a pair. And then we will report duration for this track to be duration. Now I have to write that helper function. Report duration for this track with this first granule position and this last granule position. Then anybody who's watching the VOD of this, you're going to be very fond of how I just did so much to get the exact numbers, and then I'm just going to fudge everything. If the last granule position is greater than the first granule position, then we want to subtract that away. Then the duration, I guess I don't really need to default this since I'm always going to set it. In fact, I don't even need to declare it there because this isn't C90 or C89. Equals last granule position divided by 48,000.0 to make it a double plus 2. because of how the actual processing works, I want to make sure that there's some buffer time in there, which I just globally have as 2 seconds. And so there goes everything I said about, like, getting this precise. Now, obviously, the track number I'm not going to have in there as, like, a permanent thing. That's just for testing, some initial testing here. Stud equals C++ 20, because I used contains. Aug duration 2. Aug duration 2. Whee! Break statement, not with what? 66. Oh, that's silly of me. Oh, interesting. Yeah, if it couldn't actually read it. Oh, you know what? I've made a mistake in my position calculation. Yeah. I've made quite a crucial error in my position calculation, actually. I guess it's not that crucial because the position is just used to make sure I don't reread the same thing. But these parts are not going into the position calculation. Guess that is always one at a time, so I don't really need to be that careful about it. Oh, that was a giant mess anyway. I never gave the file descriptor to skip data. I just assumed it would magically get it. Whoops. Okay, in this case, I'm not keeping track of the position because it doesn't matter there. In this case, I very much am keeping track. No, in this case, I'm still not keeping track of the position. But in this case, I am very much keeping track of the position. I no longer need this to do it. Wow, that fixed a lot of errors. 232. Oh, of course, I didn't name it first granular posts, and nor should I have. I named it start time. It's fine for it to be named that in report duration, where, like, this now is granule positions, and I'm, like, you know, dividing things by 48,000 to get it to be a real time, but I don't want to do that there. Does it have to be a const in order to do that? I suppose that makes sense. I guess, yeah, auto can't auto const. That would be very confusing. Temp slash header 1, header 2, data. Invalid argument. That sure is nothing. That sure told me absolutely nothing. Wait, let me compile this with, I've tried to mix my compilation command and my debugging command there. Oh, of course, it just exited. All I really need to know is where this is happening. Interesting. Search from. That looks conceivably within the size of the file. sbuff.size. Yeah, that's well within the size of the file. Why would I not be able to seek there? That is, in fact, -1. Interesting. It is a signed type. Oh, of course, it's an offset, not a size. Yeah, offsets have to be signed. That is the nature of an offset. Why is this happening? Why is this happening? That's very strange. Like, as soon as I started the actual search, I never closed this file, by the way. Just as an aside, I forgot to ever close this file. Hopefully I did open this file. Yes, I most certainly did. And it's certainly random access. Invalid argument. Invalid argument is such a weird... Did I, like, get my arguments in the wrong order? Yes, I did. Da-da-da-da-da-da. Yeah, it's offset then whence. That feels, for some reason, that feels like the unintuitive order to me. I don't know. I think the sort of nature of seek should come before the seek actual setting. Like, the meaning of this depends on the value of this, whereas the meaning of this doesn't depend on the value of this, so it feels backwards to do it this way. But that's Unix. That's Unix. Something's happening. Something extremely bad is happening. This file is partially a good example because there are a bunch of tracks that didn't actually contain anything, so they will inevitably read the entire file, so it's possible I was just impatient there. But it will be easier to determine if I'm being impatient when I know what range it's working in here. Oh, yeah. I mean, this is made worse by the printout, of course. You know what? The reason to do this in Powers of 2 is so that this subsearch to find the actual start of an OGG header doesn't take so long. That's the real reason. That's why you should be doing in Powers of 2. I think 64K is a better start, but yes, I should be doing this in Powers of 2. Even though I sort of convinced myself that I shouldn't. This feels slower. I don't like how much slower this feels. Finding the duration didn't take this long. And I mean, yeah, I've introduced sets and maps, but it's like a set of 10 elements or something. It doesn't, like, it's a log n time that I've added, but it's one of those free log n's. This is not right. It should not be taking this long. Something is wrong. Like, I'm not even confident that the implementation is correct just yet, but certainly the efficiency is not what I expected it to be. So the whole file is 5,260.03 seconds. That track is that long. That track is that long. Those numbers actually don't feel right to me. 5260. For comparison, let's see what the classic OG duration has to say about this. Does it say 5260.03? This one doesn't give every track. Wait, this says there's a track 0 as well as it. Okay, so at least the duration is actually correct. It's, rounding slightly differently. I'm not concerned about that. That's why I have the +2 at the end. What does this say is the duration for 1? Is it this duration or is it this duration? And if it's this duration, then what the hell am I talking about 0? So the stream numbers here, you can technically have a stream number 0, but that's just not how I've implemented it. So I'm fairly surprised by having a stream number 0 here. Did I put metadata in stream 0 or something? Is that the metadata? That could be the metadata. If it is, then I'm just being a bit foolish. I mean, I guess I could explicitly check if it's the metadata. It's a bit grotesque. Just like skip that track in particular. Yeah, I had to read the actual... I have to read the actual packet data rather than skipping the packet data in order to make that determination, which is quite annoying. You know what? I have enough other problems that I can make that a problem for later. Now, mind you, although obviously the performance of this was bad and was worse than the previous one, it is not worse than 16 times the previous one, which is what it's doing. So this is not a complete catastrophe, even though it is, frankly, quite terrible. This feels like a really inefficient way to do this search. Is there... I guess I kind of want stir, but I guess I want mem. Is there mem? Is mem a thing? Mem. I even guessed the name. Is this going to be some weird... Oh, yeah, this is some weird standard. Is there like a standard version of this? What is present in a numbered system, including... Oh, wow! Muscle mentioned in a glibc man page? Hell yeah! I mean, if it's in all the BSDs... Let's see what B string is. Usually if it starts with a B, that's from BSD. Sorry, the B doesn't stand for BSD. It stands for byte string operations, but most of the B byte string operations are from BSD. Didn't I? Wait. Yeah, B string. Where is B string in this list? What the hell? What? B string isn't... Oh, okay. This is just the page for all byte string operations. Okay, that is utterly useless. I'm just going to have to assume that mem is there. Is mem even better than this? Is this even the problem? I don't know. I really doubt this is the problem. This is just looking for an AUG. You know what, let me, just to get a sense of whether it's the problem... let me go ahead and Just sort of output the fact that I found this. Yeah, so I mean, from 374 to 841, you know, it was a couple hundred bytes. Well, yeah, that's nothing. I'm being silly here. Just gonna take a quick look at these positions and see if they seem in any way suspicious. No, it looks like it's advancing about a packet at a time. The packets seem to be about 20K around these parts. There's a short packet, but a short packet on its own is not suspicious. Yeah, seems perfectly believable to me. But you know what? You know what's the most suspicious thing? When was it taking so long? What? Whoa, whoa. Whoa, 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 whoa. Well, I guess, yeah, if it, okay, yeah, never mind. This is not nowhere near as whoa as I thought it was. If I just put this here, then I would find the same results, pretty much. It's just that there were very few tracks left to resolve. Yeah, yeah, okay. I was just being overly concerned here. Am I 100% convinced that this is actually, like, markedly slower than the previous version? Or am I just worrying myself over nothing? Oh yeah, it's way slower. The other one would be done by now. How is that possible? How is it so much slower? I am going to you know, follow this test through to the end and give it a chance. This does already feel faster. It's possible. I mean, I'm doing this on the actual Ennuicastr system, so it's possible that the CPU was a little bit more taxed before. So that took, wow, that only took 7 seconds. Okay, the CPU must be very taxed. Well, something is taking time. It's not as taxed as I expected it to be. I think I have, yeah, I've got 4 CPUs. Yeah. Oh, I've got, well, 8 pseudo CPUs, 4 CPUs. Anyway, so that took roughly 30 real world seconds. And let's do the comparison. Why? Why, though? Because it's a shell built in. That's why. Like, time, there should still be user bin time. Like, I should be able to do that without using a shell built in. It's ridiculous. Yeah, okay. So this took less than half the time. So my question is, WTF, how did I manage to make it that, like, genuinely, how did I even manage to make it that much worse? That was a lot of work to make something vastly inferior. I mean, so this is, like, this is a weird way to do it in some senses. Okay, let me try something a little bit quirky here. Let me see how it goes if I don't make any of this attempt at searching a bit at a time. And I just start from 0 and go to the end and do it all in one step. Because maybe all this hunting for a header and all of that is doing me just... it's doing me dirty. Searching from the entire file. This is now faster. Not like hugely faster, but faster. I don't understand. Oh, okay. I was, for some reason, I'm so used to ignoring system time because I expect the user time to dominate it. But of course, since this is all file reads, the system time is going to dominate it. So I'm starting to feel like my entire strategy of searching from the end was just like a horrible mistake. The thing is, it's hard to know whether it's a horrible mistake because it depends on the nature of the particular recording. But my gut tells me that the real problem is just the fact that I'm doing multiple of these duration checks, and if I do it all at once, like this one is doing, then that will be the real, that'll just be a better solution. So I am going to get rid of all of this search from crap. I'm getting rid of all of it. No longer need to look for an OG header because I can now be confident that I'm at an OG header. I no longer need to count my position because I can be confident that my position is always correct. Or rather, I can be confident that I don't care about my position. Skip data, of course, is going to change appropriately. That's no longer doing anything. There no longer is a search to. There no longer is this resolution. There no longer is this. Boy, the code sure gets simpler when you remove most of it. Oh yeah, skip data, no longer need this position part because I no longer care about the position. Get rid of there, get rid of there, get rid of there. Yeah, I mean, 10 seconds ain't great, but this is 4 gigabytes of data, and 10 seconds is a heck of a lot better than 15 times 10 seconds, which is what this would have taken before, so... the last thing I want to implement today in this apparently extra long stream is checking for the metadata track and making sure to not actually show the metadata track, because I don't care about the metadata track. I also need to rehandle pausing, which now, since I'm going start to end, I can actually do again, so that's nice. Skip data is a bit brief now, but it's fine. Okay, so now, when we are finding every track, I want to do something different here. Some reasonable maximum size, so I'm not reading some giant internal buffer. If read all into that buffer of packet from FD into that buffer of packet size is not equal to packet size, then just break. No, not Windows. I want to go here. Since I'm only looking in the header, I don't actually need to check whether it's a header packet. Otherwise, I'm just going to skip the header. And I'm not going to count the meta stream as one of the streams. So now I will get no weird zero stream reported. Hopefully. I say that very confidently. Well, this is a spectacular failure. Oh, I guess I just don't know how long 10 seconds is. Yeah, okay. There goes my meta stream. There's the durations of all these streams. Well, there's some approximation of the duration of all these streams. I mean, yeah, because the thing is, the way it was in fact, I can show you the way it was previously done. I haven't actually fixed this yet, but it just runs aug duration once for every track. And so it has to do that entire 10 to 15-ish seconds 15 times in the case of a large file like this, which is obviously doofusy. So I can make it more efficient this way. But we're not done making it more efficient, but we have done quite a bit of work on the way to making it more efficient. For next time. Stream over.